Hi there, it's Mrs. Lindquist. Hope you guys are doing well. Today we're going to start our trigonometry unit. So we're going to start talking about the Pythagorean theorem. So if you remember from geometry, the Pythagorean theorem says a squared plus b squared equals c squared. So in this, your a and your b are your legs and your c is your hypotenuse. So let me just write that down. So a and b are the legs, and C is your hypotenuse. And we know that the hypotenuse is across from the right angle. It's also the longest side of your triangle. So if we were looking here, what we see is we have a missing leg. So we can call this A or B. I'll just call it B so it kind of matches my other picture. So we're going to set up our equation. We'd have 15 squared, which is our A squared, plus B squared equals 17 squared. Okay, so we're going to get 225 plus b squared equals 289. Then we're going to subtract the 225 off of both sides. That'll cancel out, so we're going to be left with b squared equals 64. And then, of course, our last step would be to do a square root. So we'll take a square root of both sides. And so b would be 8. Normally we would say positive or negative 8, but since this is the side of a right triangle, we're going to stick with just the positive. So this length here would be 8. So what are our trigonometric ratios? Well, we have 3 ratios. And you guys, maybe if I asked you what you know about trig, I can just anticipate that everyone would say in unison, soh-cah-toa. So let's write that down and talk about what that means. So we have soh, ka, and toa. All right, so remember, S is for sine. So sine of some angle theta, and then OH means opposite over hypotenuse. Okay, so when I said theta, theta is the Greek letter, and it's pronounced like that, so it's theta. All right, so then we have cosine of some angle theta would be adjacent over hypotenuse. And again, it has to be this way. It can't be hypotenuse over adjacent. It's got to be adjacent over hypotenuse. And then our last one would be the tangent of angle theta, and that's OA, so that would be opposite over adjacent. So those are your 3 trig ratios. So let's take a look at these 2 triangles. You might say, well, they're exactly the same. So in the left one, we're going to make angle A. This is going to be our theta. So the side right across from that, that would be our opposite. The side across from the right angle is going to be our hypotenuse. And this bottom side, adjacent means next to. So whatever your angle is, the hypotenuse is going to make up one of the sides, and the adjacent will make up the other side. All right, let me just erase this little blurb here. All right, so now we're going to do our 3 trig ratios. So we'll talk about sine. So sine of theta is opposite over hypotenuse. So in this case, it would be 4 over 5. All right, now we're going to look at cosine. So cosine is adjacent over hypotenuse. So our adjacent is 3 and our hypotenuse is 5. So this would be 3 over 5. And then our last trig ratio would be tangent. So tangent of theta is opposite over adjacent. So 4 over 3. So what would happen if now we changed our reference angle? Instead of being angle A, now we made theta angle C. So let's take a look. So now if we do sine of theta, remember opposite over hypotenuse, my opposite now is the 3, and my hypotenuse is still going to be 5. So now this is going to become 3 over 5. Cosine is going to be adjacent. So adjacent means next to. So this will be my adjacent. So that would be 4 over 5. And then my tangent is going to be opposite, which is 3, over adjacent, which is 4. So 3 over 4. So how do these compare from this triangle to this triangle? Well, since the opposite and the adjacent switched, so the tangent became the reciprocal, and the sine became the cosine, and the cosine became the sine. So that's kind of what happened there. So depending on which angle you pick, the opposite and the adjacent side will be different. So let's talk about finding a missing angle. So when you're finding a missing angle, so here they want you to find angle A or angle theta. So what sides are they giving us? Well, what is the 13? That's across from the right angle. So that would be your hypotenuse. And if this is our angle, then the 12 would be our adjacent, because adjacent means next to. And we're really not using the opposite in this problem. So again, you want to think of soh-cah-toa. I always find it helpful, to write it out in the beginning so you can think about which one are you going to be using. So we know that adjacent and the hypotenuse, so adjacent and hypotenuse go with cosine. So I'm going to do a cosine problem. So cosine of an angle, so our angle we're calling it theta, or I suppose you could call it A, equals adjacent over hypotenuse. So that would be our 12 over 13. So how do we find a missing angle? Well, to get rid of a cosine, you're going to have to do a cosine inverse. So on your calculator, above the word cosine is a cosine with a little -1. If you press second cosine, you're going to get the cosine inverse. And then you're going to type in 12 divided by 13. And when you do that, this is approximation here, but you're going to get about 22.6 degrees. Now, if you don't get this, it could be that you're in radian mode. So please check your mode on your calculator and make sure you are in degree mode, not radian mode. So anytime you're doing missing angles, that's when you're going to use these inverses. So cosine inverse, sine inverse, and tangent inverse. Again, we're only going to use those when we are doing missing angles only. All right, so now let's talk about how do you find a missing side? So missing sides, again, the angle that we know is 60 degrees. So this is going to be our theta. Okay, so what sides do we know? Well, we know the side across from the right angle, so we're going to call this as our hypotenuse. And again, the side that's the one side we want, the x, is next to the 60. So next to is going to be our adjacent. So it looks like we're going to end up with another cosine problem because we have our hypotenuse and we want our adjacent. So we're going to do cosine. So cosine of our angle, which in this problem we know is 60 degrees, equals adjacent over hypotenuse. So that is going to be x over 11. So how are we going to solve this? Well, first of all, I want to get x by itself. So how do we undo dividing by 11? Well, we would multiply by 11. So then this would cancel out. And you are going to get, just type this in your calculator, you're going to just do 11 times cosine 60 degrees. Again, make sure you're in degree mode. And you should approximately get 5.5. Does that seem reasonable for this missing length? Well, it sure does. It looks like it's got, I mean, we know it has to be smaller than 11 because it's one of the legs. So 5.5. All right. So let's see here. I'm going to play around here. Can I put a box around this? Oh, look at that. Okay. So we talked about how to do missing sides and missing angles. So the last problem, actually we have one more missing side, so we'll do one more missing side here. And then maybe I'll make the last problem an extension of this. So what do we have here? So our angle we're using is angle B, which is 57 degrees. So across, if we go across from it, this would be our opposite. And then we have, of course, this is our hypotenuse. So which trig function goes with opposite and hypotenuse? If you guess sine, you'd be correct. So when we do soh-cah-toa, that's your opposite and your hypotenuse. So we're going to do sine of our angle. So sine of 57 degrees equals opposite over hypotenuse, which would be x. Okay, so now what we're solving is for x, and it's in the denominator. So how do we solve for x when it's in the denominator? Well, I'd like x to not be in the denominator, so to undo dividing by x, I'm going to multiply both sides by x. Those x's are going to cancel out. I'm going to have x times sine of 57 degrees equals 10.8. And to get x by itself, my last step would be to divide both sides by sine of 57. And those would cancel. So x is approximately, I would type in my calculator, 10.8 divided by sine of 57 degrees. And I'm going to get approximately 12.9. And then again, take a look. Does that seem like a reasonable answer? And I look and I say, yep, it's my hypotenuse. It's the longest side, so it definitely has to be bigger than the 10.8. So it's pretty good. All right. So I only have about 2 minutes left on this particular software, so I will make a little extension for the last part, which is solving a triangle. But you can do most of the problems based on these examples, so I will make a little short video to talk about solving for a triangle. Okay, I hope this gives you enough to get going on this assignment. Let me know if you have any questions. All right, take care, guys. Bye.